Hello there and welcome back to Astro Dreams. I'm so glad you're here tonight. Perhaps you've had a long day filled with the small concerns of daily life. Deadlines, tasks, worries, but tonight we're going to step back from all of that. We're going to look at something much larger, much older, much more vast than anything we encounter in our everyday world. Tonight we're exploring the universe itself. Not just a planet or a star or even a galaxy, but everything, all of space, all of time, all of matter and energy, the totality of existence, the grand cosmic stage on which everything unfolds. You have nothing to do right now but rest. Let your breathing slow. Let your body sink into comfort. Feel the weight of the day lifting away as if you're floating gently in the vastness of space itself. Because tonight we're going to drift together through 100 facts about the universe. Some will be mind-bending, others will be soothing. All of them will remind you of something important, that you are part of something extraordinary, something ancient, something beautiful beyond measure. Before we begin, if these peaceful journeys help you relax or bring you wonder at the end of your day, please consider subscribing to Astro Dreams. It helps others find their way here too, one dreamer at a time. Now close your eyes, take a deep breath, and let's begin our journey through the cosmos. Fact number 1. The universe is approximately 13.8 billion years old. This age has been calculated using multiple methods, by measuring the expansion rate of the universe, by studying the oldest stars, by analyzing the cosmic microwave background radiation, the faint afterglow of the Big Bang that still fills all of space. 13.8 billion years. It's a number almost impossible to grasp, but it means that everything you see, everything you know, everything that exists had a beginning. And that beginning happened long, long ago. Fact number 2. The universe began with the Big Bang, not an explosion in space, but an expansion of space itself. In the beginning, all of space was compressed into an infinitely small, infinitely dense point, a singularity, and then it began to expand. Space itself stretched, cooled, and from that expansion, everything emerged: energy, matter, the first particles, eventually atoms, stars, galaxies, planets, and us. The Big Bang wasn't just the beginning of matter, it was the beginning of time itself. Fact number 3. The universe is still expanding. Right now, as you rest, galaxies are moving away from each other. Space itself is stretching. This expansion was discovered in the 1920s by astronomer Edwin Hubble, who noticed that distant galaxies are all moving away from us. The farther away a galaxy is, the faster it's receding. This doesn't mean we're at the center. It means space itself is expanding everywhere, like the surface of a balloon being inflated. Every point moves away from every other point. Fact number 4. The expansion of the universe is accelerating. Not only is the universe expanding, but that expansion is speeding up. This discovery, made in the late 1990s, shocked astronomers. They expected gravity to slow the expansion down over time. Instead, it's accelerating. Something is pushing space apart. We call this mysterious force dark energy, and it makes up about 68% of the universe. We don't know what it is, but it's there, driving galaxies apart. Stretching space itself at an ever-increasing rate. Fact number 5. The observable universe is about 93 billion light-years in diameter. This doesn't mean the universe is only 93 billion light-years across. It means that's how far we can see. Light from more distant regions hasn't had time to reach us yet. Because the universe is only 13.8 billion years old, light has only been traveling for that long. But because space has been expanding while that light travels, the edge of the observable universe is now much farther away. 93 billion light-years is just what we can observe. The full universe is likely much, much larger, perhaps infinite. Fact number 6. We may never know the true size of the universe. If the universe is infinite, there is no edge, no boundary. It simply goes on forever in all directions. If it's finite, it might curve back on itself like the surface of a sphere. You could travel in one direction and eventually return to where you started, but we don't know which is true. Current measurements suggest the universe is flat, which could mean it's infinite, but we can only measure what we can observe. Beyond that, the universe remains a mystery. Fact number 7. The universe contains at least 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. Some galaxies are small, others are immense. All of them are scattered across the vastness of space. 2 trillion is an estimate based on deep observations with telescopes like Hubble, but the true number could be higher, and each of those galaxies is a vast collection of stars, planets, gas, dust, and dark matter. The universe is incomprehensibly full, not empty, full of structure, of light, of worlds. Fact number 8. Most of the universe is empty space. Despite containing trillions of galaxies, the universe is mostly void. The distances between galaxies are enormous. The distances between stars within galaxies are vast. Even atoms, the building blocks of matter, are mostly empty space. If you could remove all the empty space from the atoms in your body, you would be smaller than a grain of sand. The universe is paradoxically full and empty at the same time, full of objects, but mostly space between them. Fact number 9. The universe has no center. There is no special place from which the Big Bang occurred. Every point in space is equally valid as the center. This is because the Big Bang didn't happen at a location in space. It happened to space itself. Space expanded from every point simultaneously. So when we say the universe is expanding, we don't mean it's expanding into something. There's no outside. The universe is all there is, and it's expanding within itself. Fact number 10. The universe may be one of many. Some theories suggest that our universe is just one bubble in a vast multiverse. Other universes could exist with different physical laws, different constants, different histories. These universes would be completely separate from ours, unreachable, unobservable. We may never know if the multiverse exists, but the mathematics of certain theories, like eternal inflation, suggest it's possible. If true, our universe is just one chapter in an infinitely larger story. Fact number 11. Cosmic microwave background is the oldest light in the universe. About 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Before this, space was filled with a hot plasma that was opaque to light. But when atoms formed, light could finally travel freely. That light has been traveling ever since, and we can still detect it today, stretched by the expansion of space into microwaves. It fills the entire sky, a faint glow, the afterglow of creation itself. Fact number 12. The cosmic microwave background is nearly uniform. In every direction we look, this ancient light has almost the same temperature, about 2.7 Kelvin, just a few degrees above absolute zero. This uniformity is remarkable. It tells us that the early universe was very smooth, very homogeneous. The tiny variations in temperature, less than 1 part in 100,000, are the seeds that eventually grew into galaxies and stars. Without those tiny ripples, nothing would exist. No structure, no stars, no us. Fact number 13. The universe was once small enough to fit in your hand. In the first fractions of a second after the Big Bang, all the matter and energy in the observable universe was compressed into a region smaller than an atom, smaller than a proton, unimaginably hot, unimaginably dense, and then it expanded, rapidly, exponentially, in a process called inflation. In less than a trillionth of a second, the universe grew from subatomic size to macroscopic size. It's one of the most extraordinary facts in all of science. Fact number 14. Time itself began with the Big Bang. Before the Big Bang, there was no before. Time is a property of the universe. It emerged with space and matter. Asking what happened before the Big Bang is like asking what's north of the North Pole. The question doesn't quite make sense. Time has a beginning, and that beginning is the Big Bang. Everything that has ever happened, every moment, every event, all of time, it all traces back to that singular beginning. Fact number 15. The universe will likely expand forever. Based on current observations, the universe won't collapse back on itself. Instead, it will continue expanding, driven by dark energy. Over trillions of years, galaxies will drift farther apart, stars will burn out, black holes will evaporate. Eventually, the universe will become cold, dark, and nearly empty. This distant future is called the heat death of the universe, a state of maximum entropy, where no energy flows, no structure remains. Just stillness, silence, the end of everything, but that's trillions upon trillions of years away. For now, the universe is vibrant, alive, full of light. Fact number 16. The universe contains more stars than grains of sand on all of Earth's beaches. This is one of those comparisons that helps us grasp the scale. If you collected every grain of sand from every beach and desert on Earth, you'd have roughly 10 to the power of 20 grains. But there are an estimated 10 to the power of 24 stars in the observable universe, 1,000 times more stars than grains of sand. Each star a sun, many with planets, some with worlds that might harbor life. The universe is almost unfathomably vast. Fact number 17. Most of the universe is made of things we cannot see. Ordinary matter, the stuff that makes up stars, planets, and us, accounts for only about 5% of the universe. About 27% is dark matter, a mysterious substance that doesn't emit light but exerts gravitational force. And about 68% is dark energy, the force accelerating the expansion of space. Together, dark matter and dark energy make up 95% of the universe. We live in a cosmos dominated by the invisible. Fact number 18. Dark matter holds galaxies together. Without it, galaxies would fly apart. The visible matter in galaxies isn't enough to account for the gravitational forces we observe. Stars in the outer regions of galaxies orbit too fast. They should be flung into space, but they're not. Something invisible is holding them in place. That something is dark matter. It forms vast halos around galaxy, invisible scaffolding. We can't see it, but we know it's there, because without it, galaxies wouldn't exist. Fact number 19. We don't know what dark matter is. Despite decades of research, dark matter remains mysterious. It doesn't interact with light. It doesn't emit, absorb, or reflect electromagnetic radiation. It only interacts through gravity. Scientists have proposed many candidates: weakly interacting massive particles, axions, primordial black holes, but none have been confirmed. Dark matter is one of the greatest unsolved mysteries in science. A reminder that we still have so much to learn about the universe we inhabit. Fact number 20. Dark energy is even more mysterious than dark matter. We know even less about dark energy than we do about dark matter. All we know is that it's a property of space itself, and it's causing the universe to expand faster over time. Some theories suggest it's related to the cosmological constant, a term Einstein added to his equations. Others propose it's a dynamic field that changes over time. But truthfully, we don't know. Dark energy is the biggest mystery in cosmology. Fact number 21. The universe is flat. When cosmologists say the universe is flat, they mean its geometry. On cosmic scales, parallel lines stay parallel. Triangles have angles that add up to 180 degrees. This is Euclidean geometry, the geometry we learn in school. If the universe had positive curvature, it would be like the surface of a sphere. If it had negative curvature, it would be saddle-shaped. But measurements show it's flat. We're so close to flat that we can't measure any curvature. This has profound implications. A flat universe is likely infinite. Fact number 22. The universe is isotropic. This means it looks the same in all directions. No matter where you point your telescope, the universe has the same large-scale structure, the same distribution of galaxies, the same cosmic microwave background. This isotropy is one of the pillars of modern cosmology. It tells us there's nothing special about our location. The universe is uniform on large scales. We're not at the center. There is no center. Everywhere is the same. Fact number 23. The universe is homogeneous. On very large scales, the universe has a uniform density. If you zoom out far enough, beyond clusters and superclusters of galaxies, the distribution of matter becomes smooth. This homogeneity is why we can use the same physical laws everywhere. The universe doesn't have special regions with different properties. It's the same everywhere. This makes cosmology possible, because we can study the universe here and apply what we learn everywhere. Fact number 24. The furthest objects we can see are over 13 billion light-years away. These are some of the oldest galaxies in the universe, formed when the cosmos was young. Their light has been traveling for over 13 billion years to reach us. When we look at them, we're seeing them as they were billions of years ago, shortly after the first stars ignited. These distant galaxies are faint, small, irregular, nothing like the grand spirals we see nearby. They show us what the universe looked like in its infancy. Fact number 25. Light takes time to travel, and this means when we look into space, we're also looking back in time. The light from the sun takes 8 minutes to reach Earth, so we see the sun as it was 8 minutes ago. The nearest star, Proxima Centauri, is over 4 light-years away. We see it as it was over 4 years ago. Distant galaxies, billions of years ago. The universe is not just vast in space, it's vast in time, and we can observe its history simply by looking far away. Fact number 26. There is no now in the universe. Because light takes time to travel, different observers see different moments. When you look at the sun, you see it 8 minutes in the past. When you look at Andromeda, you see it 2.5 million years in the past. There is no universal present moment, no synchronized now that applies everywhere. Time is relative, and in the vast universe, simultaneity breaks down. It's a strange, beautiful consequence of the finite speed of light. Fact number 27. The universe doesn't have an edge. If the universe is infinite, it has no boundary. It just goes on forever. If it's finite but curved, like the surface of a sphere, it still has no edge. You could travel in one direction indefinitely and never reach an endpoint, just as you can travel around the Earth without ever reaching an edge. The universe is either unbounded because it's infinite or unbounded because it curves back on itself. Either way, there's no wall, no border, no end. Fact number 28. The laws of physics are the same everywhere in the universe. Gravity works the same in distant galaxies as it does here. Atoms behave the same way. Light travels at the same speed. This universality is what makes science possible. We can study the universe from Earth and trust that what we learn applies everywhere. It's a profound assumption, and as far as we can tell, it's true. The universe plays by consistent rules. Fact number 29. The speed of light is the ultimate speed limit. Nothing can travel faster than light in a vacuum. About 300,000 kilometers per second. This isn't just a rule for light, it's a fundamental property of space and time. As objects approach the speed of light, they gain mass, time slows down, distances contract. At the speed of light, time stops, distance becomes zero. It's a cosmic speed limit built into the fabric of reality itself. And it means the universe is bigger than we can ever fully explore. Fact number 30. The universe is mostly hydrogen and helium. These two elements make up about 98% of all ordinary matter. Hydrogen is the simplest element, one proton, one electron. Helium has two protons, two electrons. Everything else, carbon, oxygen, iron, gold, makes up less than 2%. All the heavy elements were forged in stars. Through nuclear fusion in stellar cores or in supernova explosion, we are made of stardust, literally. The atoms in your body were created in stars that lived and died billions of years ago. Fact number 31. The first atoms formed 380,000 years after the Big Bang. Before this, the universe was too hot for atoms to exist. Electrons and nuclei couldn't stay together, but as the universe expanded and cooled, electrons combined with protons to form hydrogen, and with helium nuclei to form helium. This moment is called recombination, and it's when the universe became transparent. Light could finally travel freely. This is the light we detect as the cosmic microwave background. Fact number 32. The first stars formed about 100 to 200 million years after the Big Bang. These were massive, hot, and short-lived, made entirely of hydrogen and helium. They burned brightly and died quickly. Some exploded as supernovae, scattering the first heavy elements into space. Others collapsed into black holes. These first stars lit up the universe, ending the cosmic dark ages. They were the pioneers, the first generation, and they paved the way for everything that followed. Fact number 33. Stars are the universe's factories. Inside their cores, nuclear fusion transforms lighter elements into heavier ones. Hydrogen into helium, helium into carbon and oxygen into heavier elements. This process releases energy. Light, heat, it's what makes stars shine, and when massive stars die, they explode, scattering these newly forged elements into space, where they become part of new stars, new planets, new life. Stars are cosmic alchemists, turning simple elements into complexity. Fact number 34. Every element heavier than helium was made in stars. The carbon in your body, the oxygen you breathe, the calcium in your bones, the iron in your blood, all of it was forged in the hearts of stars or in the explosive deaths of stars. You are not separate from the universe. You are made of it, built from atoms created billions of years ago in stellar furnaces. You are stardust, ancient, connected to the cosmos in the most literal way. Fact number 35. Supernova explosions are among the most powerful events in the universe. When a massive star exhausts its fuel, its core collapses, and then rebounds in a catastrophic explosion. For a brief moment, a supernova can outshine an entire galaxy, releasing as much energy in seconds as the sun will emit in its entire lifetime. These explosions forge the heaviest elements, gold, platinum, uranium, and they scatter them into space, seeding the universe with the ingredients for planets and life. Fact number 36. The universe recycles itself. Matter is constantly being recycled. Stars form from clouds of gas and dust. They burn for millions or billions of years, and then they die, returning their material to space, where it can form new stars, new planets, new life. The atoms in your body have been part of many stars, many clouds, many worlds. You are part of a cosmic cycle. Ancient, ongoing, beautiful. Fact number 37. Black holes are regions where gravity is so strong that nothing can escape. Not even light. They form when massive stars collapse at the end of their lives, or when matter accumulates in the centers of galaxies. At the center of a black hole is a singularity, a point of infinite density. Around it is the event horizon, the boundary beyond which nothing can return. Black holes are mysterious, powerful, and they play a crucial role in shaping galaxies. Fact number 38. There is a supermassive black hole at the center of most galaxies. Our Milky Way has one, called Sagittarius A star. It's over 4 million times the mass of the Sun. Other galaxies have black holes that are billions of times the Sun's mass. These giants influence the evolution of their galaxy. Their gravity shapes the orbits of stars. Their feeding events release enormous amounts of energy. They are the anchors, the engines, the hearts of galaxies. Fact number 39. Black holes can merge. When two black holes orbit each other, they gradually spiral inward, losing energy to gravitational waves. Eventually, they collide and merge into a single, larger black hole. This event releases more energy than all the stars in the observable universe combined, but it's released as gravitational waves, ripples in spacetime itself. We've detected these waves, and they've opened a new way to observe the universe. Fact number 40. Gravitational waves were predicted by Einstein in 1915, but they weren't detected until 2015. 100 years later, they are ripples in the fabric of spacetime, caused by accelerating masses, like merging black holes or neutron stars. As gravitational waves pass through space, they stretch and compress it by incredibly tiny amounts. Detecting them required some of the most sensitive instruments ever built, but now we can listen to the universe in a new way. Through gravity itself. Fact number 41. The universe is full of neutrinos. These are tiny, nearly massless particles that barely interact with matter. Trillions of them pass through your body every second. Most come from the sun, others from cosmic rays or from supernovae. Neutrinos are so elusive that they can pass through the entire Earth without being stopped. We detect only a few, in vast underground detectors. Neutrinos carry information from places light cannot reach, from the cores of stars, from the heart of supernova explosions. They are messengers from the universe's most extreme environments. Fact number 42. The universe is bathed in cosmic rays. These are high-energy particles, mostly protons, that stream through space at nearly the speed of light. They come from supernova remnants, from pulsars, from distant galaxies. When they strike Earth's atmosphere, they create showers of secondary particles. Cosmic rays are everywhere, constantly bombarding us. Most are harmless, but they remind us that space is not empty. It's filled with energy, with particles, with motion. Fact number 43. Space is not a perfect vacuum. Even in the emptiest regions, there are a few atoms per cubic meter, mostly hydrogen. In interstellar space, this density is higher, a few atoms per cubic centimeter. In nebulae, even more, and between galaxies, the intergalactic medium is extremely thin but not completely empty. Space is a nearly perfect vacuum, but it's not absolute nothingness. There's always something, even if it's just a few stray atoms drifting through the void. Fact number 44. The universe has structure on the largest scales. Galaxies are not randomly scattered. They're organized into clusters. Clusters form superclusters, and superclusters are arranged along vast filaments of matter, separated by enormous void. This cosmic web is the largest structure in the universe, stretching hundreds of millions of light years. It formed from tiny density fluctuations in the early universe, amplified by gravity over billions of years. The universe is not chaotic. It has order, beauty, structure. Fact number 45. The largest known structure in the universe is the Hercules Corona Borealis Great Wall. It's a vast filament of galaxies, over 10 billion light years across, so large that light takes 10 billion years to travel from one end to the other. Structures this large challenge our understanding. They shouldn't exist according to some theories, but they do. The universe is full of surprises, full of things that push the limits of what we thought possible. Fact number 46. Voids are vast regions of space with very few galaxies. They're like cosmic bubbles, hundreds of millions of light years across. Galaxies cluster along the edges, but inside there's almost nothing. These voids make up most of the volume of the universe. They're empty, dark, silent, but they're not unimportant. They're part of the cosmic web, the spaces between the threads, and studying them helps us understand the large-scale structure of the universe. Fact number 47. The Hubble constant measures how fast the universe is expanding. It's expressed as kilometers per second per megaparsec. Essentially, it tells us how much faster a galaxy appears to recede for every additional megaparsec of distance. But there's a problem. Different methods of measuring the Hubble constant give different results. This is called the Hubble tension, and it's one of the biggest puzzles in cosmology. Either our measurements are wrong, or there's something we don't understand about the universe. Fact number 48. Redshift tells us how fast objects are moving away. When an object moves away from us, its light is stretched, shifted toward the red end of the spectrum. The farther away a galaxy is, the greater its redshift. This is how we know the universe is expanding, and by measuring redshift, we can calculate distances, map the universe, and trace its expansion history. Redshift is one of the most important tools in cosmology. Fact number 49. Some galaxies are moving away from us faster than the speed of light. This doesn't violate relativity, because it's not the galaxies moving through space, it's space itself expanding. Galaxies very far away are carried by the expansion of space, and that expansion has no speed limit. These galaxies are beyond our cosmic horizon. We will never be able to see them or reach them. They're receding so fast that light from them will never reach us. They're forever beyond our grasp. Fact number 50. The cosmic horizon is constantly expanding. As time passes, light from more distant regions reaches us. The observable universe grows, but because the expansion is accelerating, there will come a time when this stops. Eventually, distant galaxies will recede so fast that no new light will ever reach us. The observable universe will stop growing, and in the far future, as stars burn out, galaxies beyond our local group will disappear from view. The universe will become lonelier, darker, emptier, but that's trillions of years away. Fact number 51. We live in a golden age of astronomy. We can see galaxies as they were billions of years ago. We can study the cosmic microwave background, detect gravitational waves, observe exoplanets. We have tools that previous generations could only dream of. Telescopes in space, detectors underground, arrays spanning continents. We're learning more about the universe now than at any time in history, and there's still so much more to discover. Fact number 52. The James Webb Space Telescope is revealing the early universe. Launched in 2021, it's the most powerful space telescope ever built. It observes in infrared, allowing it to see through dust and to detect light from the most distant galaxies. Webb is showing us galaxies that formed just a few 100 million years after the Big Bang. It's capturing images of unprecedented detail, and it's rewriting our understanding of cosmic history. Fact number 53. The universe is transparent to most wavelengths of light. Visible light, infrared, radio waves, ultraviolet, all can travel through space unimpeded, but some wavelengths are blocked by Earth's atmosphere, which is why we build telescopes in space or on high mountains or in deserts. We observe the universe across the electromagnetic spectrum. Each wavelength reveals different phenomena, different processes, different mysteries. Fact number 54. The universe has no preferred direction. There's no up or down, no north or south. In space, these concepts lose meaning. Astronauts often describe feeling disoriented at first because there's no gravity to define which way is down. The universe is fundamentally isotropic, the same in all directions, and that includes direction itself. There's no special orientation, no cosmic axis, just infinite space, stretching in every direction equally. Fact number 55. The universe may have no boundary in time either. Just as it may be infinite in space, it may be infinite in time. Some models suggest the universe has always existed in some form, cycling through phases of expansion and contraction. Others propose it began with the Big Bang and will end with heat death. We don't know. Time's arrow points forward, entropy increases, but whether time itself has a beginning and an end remains one of cosmology's deepest questions. Fact number 56. Entropy is the universe's measure of disorder, and it always increases. This is the second law of thermodynamics. In a closed system, entropy never decreases. The universe tends toward disorder, toward equilibrium. Stars burn out, energy disperses, heat spreads. Eventually, the universe will reach maximum entropy, a state where no more work can be done, no more energy flow. This is heat death, the final state, but it's inconceivably far in the future. Fact number 57. The arrow of time points in one direction. We experience time moving forward, from past to future. This is deeply connected to entropy. Entropy increases with time, and that increase gives time its direction. We remember the past, not the future. Cause precedes effect. Time flows. But why? This is one of physics' great mysteries. The laws of physics at the fundamental level don't distinguish between past and future, yet time does. Fact number 58. The universe may be cyclic. Some theories propose that the Big Bang wasn't the beginning, but a transition from a previous phase. Perhaps the universe undergoes endless cycles of expansion and contraction, each Big Bang followed by a big crunch, which leads to another Big Bang. In this model, the universe has no beginning, no end, just eternal cycles. It's speculative, but it's an intriguing possibility. Fact number 59. Inflation is the theory that the universe expanded exponentially in its first moments. In less than a trillionth of a second, the universe grew from subatomic size to macroscopic size. This solves several problems in cosmology, like why the universe is so uniform and why it's flat. Inflation predicts certain patterns in the cosmic microwave background, and observations match those predictions. Inflation is now a cornerstone of modern cosmology. Fact number 60. Quantum fluctuations seeded the universe's structure. During inflation, tiny random fluctuations at the quantum level were stretched to cosmic scales. These became the seeds of galaxies, of clusters, of the cosmic web. Without quantum fluctuations, the universe would be perfectly uniform, and nothing would exist. No stars, no galaxies, no life. The randomness of quantum mechanics is why we're here. Fact number 61. The universe is quantum at its core. At the smallest scales, particles don't have definite positions or velocities. They exist in states of probability. They can be in multiple places at once. This is the quantum world, strange, counterintuitive, but fundamental. And these quantum rules, applied during the universe's earliest moments, shaped everything that followed. The universe is built on quantum mechanics. Fact number 62. Empty space is not truly empty. Even in a perfect vacuum, quantum fields fluctuate. Virtual particles pop in and out of existence. Energy appears and disappears, on timescales so short that they don't violate conservation laws. This is called vacuum energy, or zero-point energy. It's a strange consequence of quantum mechanics, and it may be related to dark energy, the force accelerating the universe's expansion. Fact number 63. The Planck scale is the smallest meaningful length, about 10 to the minus 35 meters. At this scale, quantum effects dominate. Space and time themselves become uncertain. Below the Planck scale, our current theories break down. We don't know what happens. Quantum mechanics and general relativity are two great theories, can't be reconciled at this scale. We need a theory of quantum gravity, and we don't have one yet. Fact number 64. String theory proposes that fundamental particles are not points but tiny vibrating strings. These strings exist in more than the 3 dimensions of space we experience, perhaps 10 or 11 dimensions. Most of these extra dimensions are curled up, too small to detect. String theory is elegant. It unifies quantum mechanics and gravity, but it's also untested. We don't yet know if it describes our universe. It remains a beautiful mathematical possibility. Fact number 65. The fine-tuning problem asks why the universe's constants seem perfectly set for life. If gravity were slightly stronger or weaker, stars wouldn't form. If the electromagnetic force were different, atoms couldn't exist. Dozens of parameters have values that seem finely tuned. Why? Some say it's chance. Others invoke a multiverse, where every possible set of constants exists, and we live in one where life is possible. It's one of cosmology's deepest questions. Fact number 66. The anthropic principle suggests we observe the universe we do because we exist. If the constants were different, we wouldn't be here to observe them. In a multiverse, most universes might be lifeless, but we, by definition, live in one where life is possible. It's a tautology, but it's also profound. Our existence constrains what we can observe. We're not passive observers. Our presence is part of the answer. Fact number 67. The universe is comprehensible. We can study it, understand it, predict its behavior. This is remarkable. There's no reason the universe had to follow mathematical laws or that those laws had to be discoverable. But they are. Science works. Mathematics describes reality. This deep connection between mind and cosmos is one of the greatest mysteries. Why should the universe be understandable? Fact number 68. Mathematics appears to be the language of the universe. From the orbits of planets to the behavior of subatomic particles, mathematics describes it all. Equations discovered in the abstract often turn out to describe reality. Einstein's equations predicted black holes and gravitational waves decades before they were observed. Why is math so effective? Is it discovered or invented? These are philosophical questions, but they're also deeply scientific. Fact number 69. The universe has given rise to consciousness. Somewhere in the vastness of space and time, matter became aware of itself. Atoms forged in stars arranged themselves into structures complex enough to think, to wonder, to observe. Consciousness is one of the greatest mysteries. How does matter become aware? How do brains create minds? We don't fully understand, but we know it happened. The universe created observers, and those observers are now studying the universe that created them. Fact number 70. We are the universe observing itself. You are made of atoms from ancient stars. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was made in stellar furnaces. You are not separate from the cosmos. You are a part of it, a way for the universe to know itself, to experience itself, to wonder about itself. In you, the universe has become conscious. This is not metaphor, it is literal truth. Fact number 71. Life may be common in the universe. We don't know yet, but the ingredients for life are everywhere. Water, organic molecules, energy sources. These exist throughout the cosmos. Exoplanets are abundant. Many orbit inhabitable zones. If life arose on Earth, why not elsewhere? We may not be alone. In a universe with trillions of galaxies, each with billions of stars, it seems unlikely that we're the only living things, but we haven't found others yet. The search continues. Fact number 72. The Drake equation estimates the number of communicating civilizations in our galaxy. It considers factors like the rate of star formation, the fraction of stars with planets, the number of habitable planets, and the likelihood of life developing intelligence. The equation doesn't give us an answer, because many of the factors are uncertain, but it frames the question, and it reminds us that the search for life is a scientific endeavor, with variables we can measure and refine. Fact number 73. The Fermi paradox asks why we haven't found aliens yet. If life is common and the universe is old, intelligent civilizations should be everywhere. Some should be millions of years ahead of us. They should have colonized the galaxy. We should see their signatures, but we don't. The sky is silent. Why? Maybe life is rare. Maybe intelligence is rare. Maybe civilizations destroy themselves. Maybe they're hiding. Or maybe we're just not looking in the right way. The silence is mysterious. Fact number 74. The universe may be teeming with microbial life. While intelligent civilizations might be rare, simple life could be common. Bacteria, archaea, single-celled organism. These arose quickly on Earth, within a few 100 million years of the planet's formation. If life is easy to start, it might exist on countless worlds, in subsurface oceans, in atmospheres, in the soil of distant planets. We may never communicate with microbes, but discovering them would be profound. It would mean life is a cosmic phenomenon. Fact number 75. Some moons in our solar system may harbor life. Europa, orbiting Jupiter, has a subsurface ocean. Beneath kilometers of ice, warmed by tidal forces, it might have hydrothermal vents, like those on Earth where life thrives without sunlight. Enceladus, a moon of Saturn, has geysers erupting from its south pole, spewing water into space. Both moons are targets in the search for life, not on distant planets, but right here, in our own solar system. Fact number 76. The universe is not static, it's dynamic, evolving, changing. Stars are born, stars die, galaxies merge, black holes grow. The universe today is different from the universe a billion years ago, and it will be different a billion years from now. Change is fundamental. Nothing is permanent, not stars, not galaxies, not even space itself. Everything flows, everything transforms. The universe is a process, not a thing. Fact number 77. The concept of spacetime unifies space and time. Einstein showed they're not separate, they're woven together. Events don't happen in space, they happen in spacetime. A point in spacetime has 4 coordinates, 3 for space, 1 for time. Gravity is not a force, it's the curvature of spacetime. Massive objects bend spacetime around them, and other objects follow those curves. This is general relativity, and it revolutionized our understanding of the universe. Fact number 78. Time slows down near massive objects. This is gravitational time dilation. Clocks tick slower in strong gravitational fields. If you stood near a black hole, time would pass more slowly for you than for someone far away. This isn't an illusion, it's real. Time itself is affected by gravity. Astronauts on the International Space Station age slightly slower than people on Earth, by tiny fractions of a second, but it's measurable. Time is not absolute, it's relative. Fact number 79. Time also slows down at high speeds. This is special relativity. If you travel close to the speed of light, time passes more slowly for you than for stationary observers. If you travel to a distant star at near light speed and return, decades might pass on Earth while only years pass for you. This is time dilation. It's been confirmed in countless experiments. Time is not fixed, it depends on motion, and gravity. Time is flexible. Fact number 80. E equals mc squared. This famous equation tells us that energy and mass are equivalent. Mass can be converted to energy. Energy can be converted to mass. This happens in stars, in nuclear reactions, in particle collisions. A tiny amount of mass contains enormous energy. The equation reveals a deep truth. Matter and energy are not separate things. They're different forms of the same thing. The universe is fundamentally unified. Fact number 81. The speed of light connects space and time. Light always travels at the same speed in a vacuum, about 300,000 kilometers per second. This is not just a speed limit for light, it's a fundamental constant of the universe, and it determines how space and time relate. The faster you move through space, the slower you move through time. Light traveling at maximum speed through space doesn't experience time at all. From a photon's perspective, its journey is instantaneous. No time passes. This is one of relativity's strangest predictions. Fact number 82. Photons, the particles of light, have no mass. They're pure energy. They travel at the speed of light. Always, they cannot slow down, they cannot stop. From the moment they're created until they're absorbed, they move at light speed. And from their perspective, no time passes. A photon emitted from a distant galaxy billions of years ago experiences no duration. For it, emission and absorption are the same instant. It's a timeless journey across billions of light years. Fact number 83. Light from distant galaxies has been traveling for billions of years. When we observe a galaxy 10 billion light years away, we see it as it was 10 billion years ago. That galaxy today is much older, changed, perhaps unrecognizable, but we can't see its present. We're limited by the speed of light. The universe we observe is a patchwork of different times, the past laid out in space. The farther we look, the farther back in time we see. Fact number 84. The universe's age limits what we can see. Light from regions more than about 13.8 billion light years away hasn't had time to reach us yet. And because of expansion, those regions are now much farther away, about 46 billion light years. This defines the edge of the observable universe. Beyond that, there may be more universe, perhaps infinite, but we can't see it, not yet. And if expansion continues accelerating, we never will. Fact number 85. The universe's temperature has been dropping since the Big Bang. In the first moments, the universe was unimaginably hot, trillions of degrees. As it expanded, it cooled. Today, the average temperature of the universe is about 2.7 Kelvin, just a few degrees above absolute zero, the coldest possible temperature. The universe is cold, and it's getting colder. As expansion continues, temperatures will approach absolute zero. Eventually, the universe will be dark, cold, still. Fact number 86. Absolute zero is minus 273.15 degrees Celsius. At this temperature, all molecular motion stops. Atoms barely vibrate. It's the lowest possible temperature, but it's also unreachable. Quantum mechanics prevents perfect stillness. Even at absolute zero, there's residual motion, zero-point energy. The universe at its core is always vibrating, always moving, even in the coldest depths of space. Fact number 87. The cosmic microwave background has a temperature of 2.725 Kelvin. This is the temperature of the universe itself. The afterglow of the Big Bang, it fills all of space. Uniformly, no matter where you are in the universe, you're bathed in this faint radiation. It's the oldest light we can detect, and it carries information about the universe's infancy, about its composition, its structure, its history. Fact number 88. The universe has a horizon, not an edge, but a boundary beyond which we cannot see. Light from beyond this horizon hasn't reached us yet, and because of accelerating expansion, some regions are receding so fast that light from them will never reach us. These regions are beyond our cosmic horizon. Forever, we are in a bubble of observability, surrounded by an infinite, unobservable universe. It's humbling and mysterious. Fact number 89. Future astronomers may see a lonelier universe. In the far future, as expansion accelerates, galaxies beyond our local group will recede beyond the horizon. They'll disappear from view. Future civilizations, if they exist, will observe a universe that contains only their local cluster. No distant galaxy, no cosmic microwave background. The evidence of the Big Bang will be gone. They'll have to rely on theory, on deduction, on trust in mathematics to understand their origins. Fact number 90. We are fortunate to live when we do, in a time when the universe is observable, when we can see its history, when evidence of the Big Bang still fills the sky. A few trillion years from now, this won't be true. The universe will be darker, emptier, less knowable. We live in a golden moment, when the cosmos is still revealing itself, when its story is still written in light. Fact number 91. The largest scales in the universe are deeply connected to the smallest. Cosmology and particle physics overlap. The behavior of subatomic particles in the first moments after the Big Bang determined the structure of the universe today. Quantum fluctuations became galaxies. The physics of the very small shapes the very large. To understand the universe, we must understand both. The cosmos is unified, from quarks to quasars. Fact number 92. The weak nuclear force and the electromagnetic force were once unified. At high energies, they merge into a single electroweak force. This was confirmed in particle accelerators. At even higher energies, the strong nuclear force may unify with them. This is grand unification, and at the highest energies, perhaps all forces, including gravity, were one. This is the theory of everything, a single force, a single set of equations, describing all of reality. We haven't found it yet, but we're searching. Fact number 93. Symmetry is fundamental to the universe. Physical laws are the same everywhere, the same at all times. This is symmetry, and it's deeply connected to conservation laws. Symmetry in time gives us conservation of energy. Symmetry in space gives us conservation of momentum. The universe's symmetries are not accidents. They're built into the fabric of reality, and understanding them is key to understanding physics. Fact number 94. The universe is elegant. Its laws are simple, beautiful, expressed in mathematics that seems almost too perfect. Einstein once said that the most incomprehensible thing about the universe is that it's comprehensible. Why should reality be describable by equations? Why should those equations be elegant? We don't know, but they are, and that elegance is a clue, perhaps the only clue, that there's something deeper, some underlying principle, some reason. Fact number 95. The universe is probabilistic at its core. Quantum mechanics tells us that outcomes are not predetermined. Particles exist in states of probability. When you measure them, the probabilities collapse into definite outcomes, but before measurement, they're uncertain. This randomness is fundamental, not a limitation of knowledge, but a property of reality. The universe, at its smallest scales, is ruled by chance. Fact number 96. Yet the universe produces order from randomness. Stars form from chaotic clouds, galaxies from primordial fluctuation, life from chemistry. Order emerges, patterns arise, structure self-organizes. This is one of the universe's most beautiful properties. It's creative. From simple rules and random initial conditions, complexity emerges, beauty emerges, consciousness emerges. The universe is not just a collection of particles, it's a generator of meaning. Fact number 97. The universe may be deterministic on large scales, but probabilistic on small scales. Classical mechanics, which describes planets and stars, is deterministic. If you know the initial conditions, you can predict the future. But quantum mechanics is probabilistic. The outcome of individual events is uncertain. These two descriptions coexist: large-scale order, small-scale randomness, and somehow they work together, creating a universe that's both predictable and surprising. Fact number 98. The universe is still full of mysteries. We don't know what dark matter is. We don't know what dark energy is. We don't know if the multiverse exists. We don't know if there's life elsewhere. We don't know how consciousness arises. We don't know if time had a beginning. We don't know if the universe will end. These are not small questions. They're fundamental, and we're still searching for answers. Fact number 99. The universe is approximately 13.8 billion years old, but it feels eternal. Standing under the stars, looking up, it's easy to feel that the cosmos has always been, and always will be. In a sense, that's true. The atoms in your body are ancient, older than the sun, older than the earth. They were forged in stars that died before our solar system was born. You are made of ancient material. You are connected to deep time, to the long history of the universe. You are part of something that transcends your individual existence. Fact number 100. The universe is beautiful, not in spite of its vastness, but because of it, not in spite of its age, but because of it. The fact that it's comprehensible, that we tiny beings on a small planet can understand it, can map it, can explore it, that is extraordinary. The universe could have been chaotic, unknowable, but it's not. It follows law, it has structure, it has meaning. And in the vastness of space and the depth of time, we have found our place, small but connected, part of the whole. We are the universe aware of itself, and that is perhaps the most beautiful fact of all. And now, as we come to the end of our journey, let's rest here for a moment, in the quiet vastness, in the stillness between stars. We've traveled far tonight, from the Big Bang to the heat death, from quantum foam to the cosmic web, from the smallest particles to the largest structures. We've seen that the universe is old, vast, mysterious, but also knowable, comprehensible, beautiful. You are part of this universe, made of its materials, following its laws, shaped by its history. The atoms in your body have traveled across space and time, through stars, through space, through the long arc of cosmic evolution, to be here, now, in this moment. And in you, the universe has become aware. It has opened its eyes. It has wondered about itself. You are not an accident. You are an expression of the universe's capacity for complexity, for consciousness, for meaning. Tonight, as you rest, remember that you're floating through space, on a planet orbiting a star, in a galaxy of hundreds of billions of stars, in a universe of trillions of galaxies. You're moving, always moving, through space, through time, part of the great cosmic dance. The universe is vast, but you are part of it. The universe is ancient, but you carry its history in your atoms. The universe is mysterious, but you are here wondering about it, and that wondering is itself a miracle. Sleep well, dream deeply, and know that the universe holds you, as it has always held everything, in its vastness, in its beauty, in its endless unfolding. You are home. You have always been home, in the universe, in the cosmos, in the great web of existence that connects all things. Rest now. The stars are watching, the universe is breathing, and you are part of it all. Good night from Astro Dreams. May your dreams be as vast as space, as deep as time, and as beautiful as the universe itself.